Hi, in this video, I will generate the Taguchi signal to noise ratios for smaller is the better criteria. Secondly, I will generate the tables of mean for the response variable, means table for signal to noise ratio, and we will do the interpretation of both the tables. So let's go to stat, then DOE, Taguchi, analyze Taguchi design. Here you will have to select the response variable that you want to analyze. Let's suppose I want to analyze the hardness. After that, I will click on the analysis. In the analysis, I say display the response table for signal to noise ratio and means. Click on both of them. After that, go to the options. Here select smaller is the better. Then click OK. After that, go to the storage. Please click on signal to noise ratio and means. Then click OK, and after that, OK. In order to view the results, click on this window so that it will be quite easy for you to see the results. Now, the first one table is for the signal to noise ratio. This table is for the means. So, from these two tables, we can select the settings of all the parameters that will help us to achieve our response. So let's suppose I want to minimize the hardness. So I will select only those levels that will minimize the hardness. So let's suppose there is the smallest value for GA is at level 1, for PST is at level 3, for ED is at level 3, and for RG is at level 3. So now we will see the same results in the signal to noise ratio response table. So you can see it here that the highest value of the signal to noise ratio is at level 1 because minus 43 is larger than these two values. Again, for PST, we have the highest value 43.55, again PST level 3. For the ED, we have the highest value at level 3, minus 43.57, so here level 3. And RG, the highest value is at level 3, minus 43.46. So in this way, we can identify what will be our optimum setting in order to do the single optical object optimization. In order to do the multiple objective optimization, I have already made the videos on the gradation analysis, principal component analysis, composite desirability factor, and a lot of other. Thanks a lot for watching this video. Bye.